Welcome to Geometry with Mr. McCall. Be sure to like the video and subscribe to my channel for more math content. Hey everybody, today we're going to be talking about a new three-dimensional shape, a solid called a sphere. I'm sure that many of you are familiar with spheres already. You've probably played with a lot of them when you're at PE or just out with your friends. I have one right here. This is a lacrosse ball. Um, Almost perfectly spherical in a mathematical sense, probably not. It has some little wrinkles on it and stuff, but for our purposes, it's about as close to a real sphere as you can get. We're only going to be talking about the mathematical sphere, which is defined as the set of all points that are r units away from a given point called the center. This is kind of similar to how we defined a circle, because a circle is pretty much the same definition, except it's restricted to two dimensions. So here we have a couple of circles, which I'll discuss in a moment. A circle is all the points in two dimensions that are r points or r units away from the center. Of course, r is the radius. But here, if you're doing it in three dimensions, you can almost imagine that here's the center, and a radius could shoot off in any direction you want. So, for instance, and you'll have to use your depth perception a little bit here. I could have a radius kind of shooting off towards the back like this. That's still r. Could have one shooting way down here. Still r. I could have one going straight up. Still r. It doesn't matter how you slice it. Any Anything you draw, you can kind of imagine this three-dimensional here. Anything that goes from the center to the edge of the sphere is the same distance, and that's the radius. So it's all the points in three dimensions that are the same distance away. There are two things we care about when we're measuring a sphere. We want to know about its surface area and its volume, just like we did for all the other solids. And when I was learning this back in, I don't know, whatever grade it was, our teachers just kind of told us, here's the formulas, memorize them, and be done with it. But I'm going to explain to you a little bit of why the formulas are the way they are. Today, we're going to stick to just the surface area, and next time we'll talk about the volume. So the interesting thing to me about the surface area of a sphere is that no matter what, the surface area is exactly 4 times the area of a circle with the same radius. So again, the surface area of a sphere is exactly 4 times the area of a circle with the same radius, which seems very, very convenient. So in writing, that would be 4 pi r squared. So basically, what I've done here is I've drawn a circle with the same radius. I know it's scaled down a little bit, but basically, if I were to somehow cut these circles out and wrap them along the sphere, it would be an exact covering. Now, the only problem here is that, like, if I take, something like this little glasses cloth, right, and I try to wrap it around the sphere, it doesn't exactly work. And I know this isn't a circle, but you can see that there's little wrinkles in it and stuff. It doesn't quite work out the right way. And if I had the circles, maybe I could cut it a little bit, but it just doesn't seem like it's going to fit smoothly. Yet it does. I don't think anyone in real life has really cut out 4 circles with the same radius and wrapped them on a sphere before, but theoretically, you could do it. I always found it odd how convenient some of these formulas are, how it's not some random approximation. It's a completely normal number like 4. Now, I'm not very good at doing 3D modeling, so I'm going to put a link on Schoology for another video from a channel called 3 Blue, 1 Brown, which in my opinion is, I'll go ahead and say it, it's the best math YouTube channel that there is. And his channel has 2 explanations of why the surface area of a sphere is exactly 4 times a circle with the same radius. This fact was actually discovered way back in ancient Greece by Archimedes. He was actually so proud of discovering the surface area of a sphere and also the volume of a sphere, which we'll discuss later, that he requested to have an image of a sphere inside of a cylinder and carved on his tombstone. So he thought it was a pretty big deal, and having worked through the proof myself by hand, the fact that he did it back in ancient Greece and I struggled with it here in the 2000s, it says a lot about how big of an achievement it was for him. Anyway, I'm going to provide a link to the other video, and I'll see you next time.